Hello. Yeah, so hello everyone. Am I audible? Can anyone confirm?
Yes, sir.
Okay, thank you.
Yes, sir.
Thank you. Just wait for 2-3 more minutes. Let others join, then we will start. Okay, so let's get started. So, first of all, welcome you all for this problem solving session on compiler design, which is taught by Professor Santanu Chattopadhyay. I am Saurabh from IIT Patna. I am a PhD scholar. So, every Tuesday I will be taking this class, and in this class I will try to first discuss about the weak content, and then we will go through some previous year questions and solve them, because it's a long session of 2 hours. So if Google Meet does not permit us, so we may rejoin this session again after 1 hour. So just be attentive, and if there is any doubt, just comment it on this comment section. I will surely uh, try to solve that doubt. And please keep your speakers off and just let me know the doubts through chat only. And if I am not able to listen your doubt, then only open your mic and tell me. Okay. So uh, in first week content, there was basically the introduction part in which Sarah taught about what is actually compiler, and then how it is different from assembler, then interpreter, and also the various kinds of and parts of compiler. So first I am sharing this week lecture slide. We will discuss a bit, and then we will come to this part, the problem solving part. Okay. Um, please, Rakesh Kumar, please mute your speaker. Okay, just comment me whether my screen is visible or not. Is my screen visible?
Yes, sir.
Okay.
Yes, sir.
Okay, thank you. So the let's go through the slides first, then we will come to the problem solving part. So in first week, actually, in compiler's introduction, the concepts covered were what is compiler, then what are the applications, then the phases of compiler. This is just for a revision purpose, and then we will jump to the questions. Then the challenges in compiler design, then compilation process, and an example of that. So basically, why we use compiler is because uh, our system, our computer system actually doesn't know about what language we actually use in our day-to-day life. So we want a software that can convert us, our language, our program to a form in which the machine can understand. So the compiler is actually a software that converts source language program to a target language program. Source language program is actually uh, the program we write, and target level is you can say uh, the language which machine understands here. Okay, in this context only. Uh, so if there is any error, if there is just mute your mic. Please mute your mic. Okay, thank you. Okay, okay, thank you. So, when there were no compilers, there were some problem. What were the problems? We have to make the system understand what we want to make them do, and that's why there were hand-coded machines, hand-coded machine codes. So, in primitive systems, when there were no compilers, we actually write the assembly languages, which are actually uh, based on the commands which uh, system can understand. If you can remember, if you have gone through, you may know about the codes: three address code, two address code, and assembly language codes, other assembly language codes. So those were used in earlier times, but uh, those were actually hand coded. So programmer has to provide each and every logic to the in such a way that machine can understand. But when this compiler was designed, the most of the problems were solved. How? It basically uh, takes a source program and when there was no compiler, there were errors, and you just put your program on machine, and after some time, after a long period of time, you come and just see there are error messages, there are errors, and then again you start over from very beginning. So that problem the compiler has solved. So what compiler does is that it takes a source program, it actually compiles it, means passes it through some set of rules which actually tell it it's about that whether this program is written clearly, whether it is understandable to the machine or not. If not, then it provides any error message. If there are some conditions based on which program can execute but it is not fully correct, then it throws a warning. And actually, as an output, it provides a target program which machine can understand. Okay, so the next was how many compilers. It is impossible to quantify number of compiler designs because as the computer science is growing, there are lot of languages are coming in the market, and due to that each language has its own compiler, and each of the corporations using it from very scratch. They are some of the corporations are every time just creating a compiler for their users, and which provides some ease to their task. So that's why we cannot quantify the number of compilers designed for a certain language. Now, what are the applications? First is the machine code generation. So what it does is that it takes a source language program, say it is a C++ program, to a machine understandable one, like say byte code, okay, in form of 0 1. Okay, so what we are doing, we just take actually a single language program which we can write, we can provide it as input to the machine, and then we want machine to understand it. That's why we are compiling it. So it basically takes care of such semantics, or you can say rules. Okay, last point is that compilation also generates the code for syntactically correct programs. So if there are any kind of means wrong things or wrong code in the form of syntax, if a syntax is wrong what we want to provide, then also it throws some error. Then second is format converters. So if there are two software packages which are not compatible to each other, then or we can say are from different vendors, so it basically provides a common platform kind of code, like a byte code which can be understandable for each of the machine. That's why it can be used as the format converter also. Then there is silicon compilation. In early ages, there was silicon compiler where we actually provide such input from our side and just feed it to an integrated chip, uh, which is so it actually automatically synthesizes a circuit from its behavioral description in language. There was VHDL and Verilog and etc. languages with the help of which it was coded. Then there is query optimization. So there is a phase in compiler design which was code optimization. It actually tries to optimize the query in such a way that uh, we may need some less complex processing. Okay, so in terms of time or space. So we want actually we what we actually want is what we provide as input. We want it to be get in the fastest form in case of processing. So what it generates is a proper sequence of operations that is suitable for fastest query processing. Okay. Then there is text formatting. These are basically uh, we can say that in compiler design there are phases. It is also a phase where we actually take the source code and we generate the target code. So it's kind of a target code only where we take some language as an input, and in output we want to generate a text which is in actually in a predefined format like in latex. So now coming to the next part, the phases of compiler. So this is the main thing what we have to go through in this overall course. So in this, uh, the first phase is the lexical analysis, where we actually generate the tokens. Tokens means chunks of words, or you can say uh, uh, the units which we cannot divide and which can be identified by the compiler. So in this we take the input, and as the output we actually get a token. Means if there is there is a string, it generates some tokens from it. How it does, I will show an example. Then there is syntax analysis. It checks about whether there is any kind of error in syntax or not, whether it is following certain grammar which we provide to the compiler, because compiler takes a grammar based upon which it evaluates the program and tells the system that it can be passed through you or not. So in syntax analysis, the uh, main benefit of this phase is that it basically checks the syntax. And then in semantic analysis, it checks about certain rules, whether it is following some kind of semantic or rules or not, which are predefined for a grammar or not. Okay. Then there is intermediate code generation, in which we take the semantically correct code as input, and then we actually generate an intermediate code, which is generally we can say three address code or two address code, which we can feed as input. And uh, means if we want to generate a target code in like an assembly code, so we actually provide an intermediate form of that code. Okay, how we will provide, I will let you know. Then there is code optimization, which basically tries to make the code optimized in such a way that it can take less number of variable or less complex processing. So we use this phrase in that manner. Then there is symbol table management. So symbol table is basically a table which stores each of the symbol used in that grammar with their value and their type. So when we use symbol table, we when we just say if we are going through semantic analysis phase, so there we want to just go through the symbol table, and let's say there is some input which is in incorrect form. So let's say we are taking some integer, and we in result we want float. So it first checks the symbol table whether the input we are providing is actually float or not. If not, then with the help of semantic analyzer, it basically takes uh, just a second. Okay, so in let's start over. So in symbol table, let's say we are given an input as integer variable, and then we want some output in a float form. Okay, so what it does, when we go through the compiler, it will actually tell about the again it's disconnected. Okay, can anyone confirm whether am I audible or not?
Yes, the order.
Okay, thank you. So sorry, there is some network issues. I am getting disconnected again and again. So okay, uh, I am starting it over again. Uh, in symbol table, we store the value of symbols and their type. Let's say we are storing just types for just typecasting purpose. Typecasting means we want to convert one data type to another data type. Now, if we want to do this, if we are given some input as int, and we want output as float, so first it will in semantic analysis phase, it will go through symbol table. So it will see the input value we are taken is actually in int form. So it will apply some rules which are defined in semantic analysis and convert it into the float. Okay, so that is the means role of symbol table, that it stores the type of the variables, means the tokens we are using, and at last then it tells that it is meaningful or not. Okay, then in case of error handling and recovery, if there are some debugger attached to a compiler, or we want to handle some errors, we want to just overlook some errors, then we can this phase is used. Means it will not use if there are some errors encountered, then it tells compiler that nothing has happened, you can go. Or we want if it wants that if error we don't want to handle, we just get out of the program whenever we get error, then that part is also, that can also be done in this error handling and recovery part. Means if error is encountered, what we have to do, that part is done by this error handling and recovery phase. Okay, so this is the well known and most popular diagram of this compiler. So whenever we provide a source program, the source program actually is fed to this lexical analyzer, and after lexical analysis we get some tokens we feed it to syntax analysis part. After this phase we get a parse tree, which is actually uh, which may or may not be semantically correct, which may or may not follow the rules which are predefined for certain language, certain programming language. So to check that correctness, we go through this semantic analysis phase. If it is semantically correct, then we go through intermediate code generation phase, and then we actually um, generate the intermediate code and feed it to target code generation part. And these two phases are actually interchangeably used in sorry these two phases can be means replaced with each other, because ultimately our goal is to generate the target code. We can apply target code optimization after intermediate code only, and then generate the target code. And for error handling and recovery, we have this is actually attached to each of the unit, each of the phase of the compiler, because errors can happen in multiple ways and multiple times, and symbol table is also attached to each of them, because the symbol table, the role is to actually provide the information about the input, whether it is reliable input, or means whether it is valid input or not. So these two phases are actually connected to each of the other phases. Okay. So first part in this compiler design is lexical analysis part. Just a second. So what we do in lexical analysis part, lexical analysis basically scans overall program. Then when the program is scanned, it removes all the white spaces, comments, uh, what we say it as the cosmetics. Then actually it expands the user defined macros, like in C++ you have that has include libraries. Then so it actually replaces that those code with the library code in the system, in the program. Then there is foreign word which is not actually recognized by the language that it also tells. And at last it provides a token, uh, some tokens. And the major thing is that we generate it with the help of automata, finite automata. So in theory of computation, you have gone through this finite automata. So if there is some machine which can clearly identify whether it can be identified as token or not, then means finite automata is actually a machine in general, just for the sake of if anyone doesn't know about it. So consider it as a machine where we input some text, and follow it goes through different phases of machine, and after that, if it goes through the means it passes through the machine, then it is a valid for that means language, otherwise it is not. So we actually provide a finite automata, and mm, if we provide the expression to the finite automata, if it passes through it successfully, then we consider it as a token, otherwise not. Okay. Then there is syntax analysis phase, in which we take token as input, and we actually we are given certain rules for the grammar. We tell it as grammar rules, and based on which we construct a parse tree. And if it the parse tree if it goes through the parse tree successfully, it follows the parse tree successfully, then it generates a syntax tree. Otherwise there is syntactical error in a program. Then there is semantic analysis part, in which what we do is that there is there are some variables and expressions, and there are some rules. Okay, there is static and dynamic scope. So uh, consider there are some rules, and If it is not followed by some languages, then means we have to throw some error, otherwise not. Okay, so the input in this phase is actually the syntax or parse tree which we get from syntax analysis, and after that we provide a semantically correct parse tree as an input of this phase. Okay, so this is about the syntax semantic analysis. Now there is intermediate code generation, in which it is actually optional, because in some languages, in some compilers, it directly generates the target code after semantic analysis. So it's you can use it as a refining phase, where we just retarget the code from one processor to another. Okay, so if okay, please join on time. Okay, so there are whenever we tell about this phase, if there is a certain programming language and we want some, please join on time. Every time you will join, the fluency will be affected. So in intermediate code generation, we actually generate a kind of hypothetical machine instruction, which will be actually later can be used as uh, for this target generation part only. So like there are in target code we have assembly code, but in between target code and C++, there is some code which can be a medium from one language to another language, which can bridge a gap between these two. That's why we are using it. uh, I will show an example how we can use, how it works. So just see this, there is some program, there are some phases. If there are two machines, we can generate intermediate code and we can provide it to different machines, so they can use it, the code, they can interpret the code in their way. That is the only thing intermediate code generation does. Then there is target code generation, which is actually uses template substitution from this intermediate code, and after that it provides some temporary variables which are user defined, and then packs all the these instructions to the feeds all these instructions to the CPU registers. Then there is code optimization, in which there are uh, the code is divided into basic blocks. Then we just try to optimize the code. Optimization means we want less resources to be used. Then the main optimization we does is actually the optimization of the loop, because in loop certain statements are actually repeated multiple times. Then symbol table is a data structure holding information about all symbols defined in the source program. Okay, so each of the symbol, whether it is identifier, it is operator, or it is delimiter, everything will be defined in the symbol table. If it is not in a symbol table, then there will be certain errors, there will be some warnings that it is not, it is a foreign kind of word for that compiler. So it is generally created by lexical analyzer and syntax analyzer, and global data register needed to minimize searching time. So and the last phase is actually error handling part, which I already told that if there is certain error, what we should do in that program. Now the challenges are first is language semantics, then hardware platform. We should go one by one. So in language semantics, in like in case we have to fall through or not, means we have to go through certain case or not. Then in loop, uh, there are certain compilers which actually remember about the last value in the loop. There are some compilers which not. Then break and next. There are these challenges are actually discussed already. All things are discussed. Then hardware platform, whether it is using some uh, different kind of instruction sets or not, like syscan or RISC. Then there is operating system and software, which kind of loader it is using, how it is linking the object files. Object files are actually the output of the compiler program, which actually links all the libraries together with the program and feed it to the loader, which actually at a final provide the output to the system. Then there is error handling part, then adding debugging, optimization, runtime environment. So I think most of the things are done. Now we should go through some questions. Okay, so let me share the screen. Okay, so I am taking an example with the help of which I will show how these phases actually work. So for example, we are given a source program. So in from here only, if you have any doubt, you just comment. Okay. So source program is like this. In this, we are actually something x is equal to a plus b multiplied by c. Then there is some delimiter, and we are given. Okay, we are given some statement. So this is the source program. In lexical analysis, for lexical analysis, we are given some pattern. The pattern they are giving L, L or D multiple times. Okay, this is the pattern we have to follow, and we are given a context-free grammar. There may be some terms which are not known to you, but just be with me. I will just provide some essence, and in later problem solving sessions, we will go through these terms also in a broad manner. So we are given this context-free grammar where S derives id equal to expression delimiter plus t terminal Okay. So now uh, let's start with the pattern. These are the inputs. Okay, these are the inputs we are providing, uh, we are provided in this program. Now we have to perform overall compilation. Okay, so for lexical analysis, if we are going through this pattern later, uh, so in source program, there's what this pattern is telling. I am just defining it. It is telling the in the source program there should be some, at least one letter that is denoted by L. Then there may be letter or a digit, plus is or letter or digit that can be iterated multiple times. Okay, so if we pass this string through this pattern, wherever this pattern will follow, we will just tell the compiler that it is a valid token. Okay, if this expression is in uh, each of this uh, source program, each of the word like x equal a plus b asterisk then c then delimiter or semicolon, you say, we will pass each of this to this pattern, and after going through this pattern, if it is following this pattern, then we will uh, classify them as a token. Okay, uh, so just provide the source program a plus b to c, then statement. So this is actually a comment, so it will not be there to just perform lexical analysis. So after lexical analysis, we will pass it through this. So X is a letter. Okay. Let's say each of the token as identifier or operators we are using. So X we will classify it as identifier, then equal to identifier token, then A will be classified as identifier token, then ID, then C. Sorry, that will also be ID, and then there is this delimiter. Now we will apply syntax analysis. In syntax analysis part, uh, we are given this grammar, context-free grammar. Let's go through it. Uh, so first expression is telling S derives ID equals E, then delimiter. So ID is there, equals is there, we are here. Now we have ID. So for E we have two derivations, we have E plus T or T. Okay, so we have to derive this ID plus ID from here. We are done till here. Now so we will go through the grammar, the expression which is actually used for this E plus T. Now E can derive T, T can derive F, F can derive ID. So we are now got this ID. Now again there is ID plus, then we want id into id. So we there is the operator. So we will go through t multiply by f, t will derive f will derive id, then f derives id. Okay, so what we get is that there is id, this id, then equals id plus id multiplied by id, and we will go through this. So now uh, we can say that it is syntactically verified. So it is passed through this. Now we will go through the semantic analysis part. So in semantic analysis there are no such rules provided. So it means it is following this one. So if there are no explicit rules, then we can also say it is semantically verified. Now we will go through the next part, that is intermediate code generation. For semantic analysis part, I will show the another example where we will take some different data types and we will convert it in semantic analysis phase. So intermediate code generation, what we do, let's consider that we want to generate 3 address code. So we will take means compiler will take a variable where it will store 3 addresses. This is the final address, these are the inputs. Then there is another temporary variable. So this is intermediate code. Then consider there is code optimization phase where we want to reduce number of lines. Okay, so what we can do is t1 is equal to b into c, and x is equal to a plus t1. Okay, this is eliminated. Okay, now target code generation, which actually generate the assembly code. Okay, let's consider it is taking assembly code. So what we are doing here, we are doing multiplication of b and c. So let's consider we are storing b value in register 1 and the other in register 2. So what we are doing, r1 r2, then we have to add. Let's consider we are storing a in like this way, a in r0, b in r1, c in r2. Then r2 we have to store it in some x memory location. Okay, so in this way the assembly code is generated. We can do this like we can apply target code generation part after this also, and then apply this code optimization part and again generate the target code. That is also fine. So these are different ways based upon the compilers we are actually using. So this is a simple example. Is there any doubt in this example? Just comment. I am waiting for 2 minutes. Just write in comment if there is any doubt in this example. In parse tree there is more than one, then that grammar syntax will be correct or not. That will be ambiguous grammar then. That depends on compiler. Uh, means ultimately we are generating any parse tree, then if grammar is ambiguous, it can generate more than one parse tree, but it should follow the means it should we are if we are able to generate parse tree, then it is fine. Oh,
Sir, you are not audible.
hello, hello. Am I audible now?
Yes, sir.
Okay, thank you, thank you.
Yes, sir. Yes, sir.
Okay, thank you. There is some internet issue. Okay, so if there is any doubt, just comment. I'll wait till 7:55, then we will proceed for our next part. And also another example for semantic analysis part. Okay, okay. So if everything is fine, um, My internet is actually unstable this time. So let's go to the next part. First, I want to go through some previous year questions. Then we will see the um another example in this context to clear the doubt about this. Okay. Nice question. Uh, if ID is equal to ID plus ID into ID, how compiler knows multiplication need to be done before addition? Compiler doesn't follow this BODMAS rule. Compilers just follow the rule which we tell it in form of this context-free grammar. If we will not specify this rule e plus t or t, and we just specify e into t or t, and then t plus f into f, it will just not follow the multiplication need to be first principle in its context. Okay, compiler don't know. Okay, so as we the grammar we will feed to the compiler, that will actually uh, be the responsible, that is actually responsible for the means how it will evaluate the expressions. Okay, just a second. So okay, I think the doubt is your doubt is solved, Jobin. So the grammar we will feed will tell whether it has to perform multiplication first or addition first. Okay, it don't know about Bodmer's rule at all. Then okay, so let's go through some previous year questions. They will uh, grammar feed right. No, I am not able to understand what you want to ask. You are just telling if we are doing um, something like this, E derives T, then E derives E plus T, but it will not pass if we, it will derive F. Okay, so there is associativity rule. So actually that is also up to compiler. Okay, if you see this one and this one is actually same. Okay, so it is left associative. Okay, what is T and D? Not D, it's ID. Okay, not it's just an example of some kind of pattern if it is following like uh, one by one. Okay, okay. So first, Jobin, for you, there are associativity rule. There are derivations based upon which it basically generates the parse tree. So if it is left associative, then left one will derive the this and this is same. So the priority will be E will derive E plus T. That is fine. Yes, you want. L is letter, D is digit. That is not T, that is L. That is just a simple example. It is not actually performing here. It is just kind of example that you may have this kind of pattern to follow to generate a token. So like here, if we follow this, there is L. It is letter. It is letter. It is letter. It is letter. Okay. So like a letter or digit. Okay. For that only to generate the tokens or identifiers, you can in specifically to identify to generate identifier we are using this pattern. If it is letter or digit or set of letter digit we are using. Am I confusing it with precedence of operators? Yes. uh, actually operator precedence is there, but if we are writing the grammar in such a way that it is not following that BODMAS rule, then it will not follow. Okay, if we will go through the operator precedence in a generic form, it will follow. Okay, I think that is more specific uh, to the point. So everything what it is doing based upon its grammar, if it is able to generate the sequence, generate the tokens, and generate a parse tree, then it will go through the machine, the output machine. Otherwise, there will be some error, and what operation it will perform first, that is purely dependent on what we are feeding to the compiler, what grammar it is following, and what precedence it is following. Okay, now, so coming to the previous year questions. Okay, so the first question was, what role does intermediate code play? So these are very simple questions, and it is the first week, so there are mostly subjective or objective, mostly point to point answer type questions. So just comment your answers. I want everyone to comment answers. There is no grading for it. Just comment. I want to see what you are thinking. And if I tell anything wrong, just comment, because I am also a student. You are also a student. Let's discuss in a more generic way. Okay, if I say why you are telling A, just write in one sentence why. Why B, why C, why D. Just write in one sentence if you can. Yeah, you are right. Shreyas and Jovin. Uh, to later modify for different machine, say processors. Right. So its answer is A. As I have discussed in the PPTs, weak PPTs, there was some previous phases. Then after that, there was intermediate code generation, and with the help of this, it generates some intermediate code 1 and 2, which may be compatible for different machine 1, machine 2. Okay, so right answer is answer A. Option is option A. Sorry. So that is fine. Is there any doubt? If not, then I can proceed. If anyone has any other opinion in his or her mind, then he can also write. If anyone thinks there is B, C, or D. Okay, so program analysis it doesn't do, because program analysis is uh, part of this lexical analysis part, because it scans overall things. Then code optimization, there is another phase. Then code check is in general sense, if we say we go through parsing, or we can say syntax and semantic analysis, where we check the code. Okay, so BCD is not correct, answer is A. Okay, this one. Hmm. For this one, why D and why A? Someone has written D. Yeah, A is the right answer, because we scan overall string, overall input in lexical analysis part, and after that we actually go through other parts. Okay, so it is very clear. We are given some input, and we generate the tokens. Okay, there is some input. We go to lexical analysis part, and we generate some tokens. So basic work of it is scanning and then generating tokens. Next time onwards, I request everyone to just join on time, because every time I have to admit you, I have to means recover my fluency again, and also I have to switch the windows. So that is also uh, means bad for the study. Okay, so let's so it is fine. And again, is there any doubt in this? If there is any doubt, if anyone can comment if it is not A or something else. Okay, so that's fine. Then coming to this one, just comment your answers. Why not D? Okay, why not D? Name of the phase in which compiler scans the input sequence. Just see this word, input sequence. Okay, this input sequence is actually the input of lexical analysis only. Okay, the syntax analysis part basically takes tokens as an input. Okay, not, it doesn't take, it takes token only, not input sequence. Okay, not input sequence as it is. It doesn't know about what you are writing as a variable name or identifier. It just knows that I will get some token, I will evaluate it. Okay, but if you will write a plus b is equal to c, it don't know about a, b, c. It just know identifier plus identifier into identifier. That's it. Okay, yeah, Rakesh. Okay, so most of you have provided his answer as C. Someone has written B. Why B? Due to assembly language? No. Assembly language, assembler builds program for assembly language, but we are taking program as we are taking high level language and translating it to assembly language. Just see this, translating it to assembly language. So that is actually part of this compiler only. Not D, not D. Uh, Not interpreter. Interpreter just interprets. It means it goes through one line by line, but we are taking a program overall. Yes, right, Shreyas. In interpreter, we take one line at a time. I am telling program takes. Okay, so it is compiler C. Okay, so compiler what is does source target in between there is a compiler, but what we provide is program, but interpreter we provide line by line, then the target. So there is no program, there is line, there are lines. Okay, okay, fourth one, comment your answers. What is debugging, by the way? Debugging is actually we are trying the compiler to, we are making compiler to learn by its own and just resolve the errors. So how it can do? One has written A, then C, then D. So execution, it doesn't make sense. Slower execution is not there. That is fine because we are taking overall program at a time. None of the above option is incorrect. D is not the correct option. The answer is between A and C. Now comment again whether it is A or C. Yeah, fine. Printing variable values doesn't make sense because it will just provide you the description of the error or the values, but it will not tell how to debug it. Okay, so for debugging it, what we want is some additional code that should be there which can resolve the errors. Okay, so if there is code, if there is a code and we are feeding it to compiler, so if there is some error, so we should provide some certain additional code which can debug these errors. Okay, for debugging. Okay, additionally we should tell the compiler that that depends upon compiler to compiler, that is not specific for most of the compilers. So in early ages there were some problem solving based compilers, but not there was in some compilers there were no such ease of debugging. So in later stages now there are compilers which can debug the errors by their own. Okay, so they actually need the additional code embedding, means there should be additional code which can take error as input and provide debug debugged code as output. Okay, so answer is C here. Okay, so fifth one was same as given in the assignment, this year assignment, so I am not taking that. Coming to the sixth one, just comment your answer. A. Most of you have commented A. Yes, that is right. That is right. Anyone can comment why it is right? Just be interactive. There is no problem commenting. If you are commenting anything wrong, there is no problem because it is faster and need to memory. Registers are faster. Processor directly access register. Register is fast. Yes, register is faster. And who is written this swap space? Why it is swap space? Why it should be swap space? We are not actually um specifying which kind of swap space we are using. Okay, so generally what we use it as CPU registers. What is swap space? Swap space is we can say we can create in memory itself. uh, Means there are certain spaces where we can take those values and swap in between. That is very literal thing. Okay, so I think that is about the memory only. Yeah, that is also correct. Processor external memory. What I want to tell is that uh, we here we are not specifying which kind of swap space we are using. So in general terms, we will go. We can tell that we are going from primary to secondary memory. That is also fine, but their speed is also very less. Someone has commented. Part of secondary memory to main memory. Yes, that's fine. In computer architecture, you have heard about it. So swap space is having actually less speed than main memory, is also having less speed than the registers. So answer will be A. So any doubt? Okay, coming to this one. Mm-mm. Yes, for this one just comment the answers. It's very simple one. Actually, most of the time it is discussed in this course videos by HDL. Just go through the lecture once. You will see professor has mentioned it that uh, we use actually silicon compilers, silicon compilation. Here we actually provide the user specific code, and we actually fabricate it in the silicon based registers or silicon compilers as integrated circuits. Okay, we take code and feed it to integrated circuit ICs. Okay, that is actually made of silicon. That is silicon compiler. It is C. Then coming to the next one. If anyone knows about HDL, please comment. I don't have idea this time. I haven't gone through. But yeah, in next lecture I will tell. Which of the following is the result of compiler? Hmm, actually, all are correct. So all of them are correct. If you remember that slide where there was some kind of this kind of diagram, there was error, there was warning, then there was target, then there was source. Okay, so target code is one thing that is all that will always be there. Okay, that is the main function of this compiler. But if there are certain errors, it will tell us that your program is not well. Just go through different way, or just perform some tasks to improve the program, so that I can feed it to the your machine. Okay, and also the warnings are also there. So if there are certain things like we are just performing typecasting and it is not compatible, but due to the certain grammar or certain rules it can perform task also. So it will just perform the task, but it will tell that there are some errors, you should prevent it. There are some warnings, you should prevent it, that with the help of that the program may execute better. Or if there is some issue, like there is some previous libraries which are not used in the current code, then compiler if compiler has previous codes also, then it will just warn that uh, you should for better use of code you can use this as a warning, and you can use the different function for that. Okay, so this is the traditional one, and these two are that we don't want from compiler, but all of them are actually correct, and are the outputs result of the compiler. So all of the above, D is the answer. So these are the previous year questions I have collected, and if there are any doubt in these questions, I will wait for 2 minutes. It's 8:23 till 8:25. If there is any doubt till now in these questions, otherwise I will go through the go through one more example where in which we will try to use this semantic analyzer also. Okay, in comment section, and also any doubt about lecture. Question number 4. Okay, so compiler helps in debugging via. Okay, so if we say it's one, it's A, what it is telling, printing variable values. So what it will do, it will just inform us about this error. Okay, error, not error, actually the variable names that will not add any kind of information which is actually based for error only. Okay, if we are just printing variable values, how can we say where is the error? So that is not actually the correct answer. Second is slower execution of program. Uh, that is actually not if compiler actually doesn't do this slower execution. If you go through some literature, some books, you will see it depends on the compiler. Uh, It means speed is not the thing, because it doesn't know about the code, whether the code is actually right or wrong. Okay, it scans everything. And hello, yeah. So if it scans everything, everything is in form of identifier and operators and the tokens only. Means we have only tokens. So slower execution doesn't make sense in this case, because it doesn't know where is the wrong thing. It just passes through each of the phases of the compiler, and then it knows whether there is error or not. So if there are some errors, uh, that we will know only when we execute the things. Okay, if and during execution compiler doesn't know about this, whether there is error or not. That will be some kind of output, as we discussed in just some time ago. Then additional code embedding. So in nowadays compiler, we actually provide certain code to compilers which can actually easily debug these things. Okay, means we will provide some additional code. We will feed the compiler with some additional code so that it can handle the error implicitly by itself only. Okay, that's why I have marked this additional code embedding here, because for error we provide some program which can tell the compiler how to handle this error. Okay, so additional embedding, what it does, that it takes the code, the error part, goes and executes it on this additional codes, and then this additional code actually tell the compiler what to do if there is some error. Okay, so instead of telling whether there is some error, compiler will actually debug it. Question number 8. For silicon compilation, you just go through the lectures, you will see. Okay, silicon compilation is in lecture slides only, and what silicon compilation is does is actually, uh, in this we actually take the code and feed it to IC. IC means integrated circuits we use for purpose of this, means main circuit in CPU. Okay. Uh, will you solve problems in lexical analysis today, because tomorrow is the last day for submission assignment 2 also, particularly 14 assignment 2 we need clarity. uh, so, we aren't told about actually about this. We are told to take week by week. So from today I will just take simple examples only. So in lexical analysis, what do you want? I don't have questions actually for lexical analysis today, because I prepared for introduction only. There are 12 weeks, and we have to take week by week 12 lectures. So today's week lecture is for week 1 only. So I can provide you some gist about this lexical analysis, but uh, I can't tell about this um, specifically for week 2 content. Question number 2. Hmm. Scanning, just it is very clear. You just see this sequence. Input sequence is the input of lexical analysis only, nothing else. In syntax analysis, the input is token. This is your first class. This is my first class also. It's first problem solving session only. then 1 or 5. 5 we don't have. I can't discuss because it is in assignment, this year's assignment also. Means similar kind of question. So no, course is actually started from 3 week ago. It's third week of course. We are told to take problem solving sessions from this week only, so that's why I am taking it from today. Yeah, okay, fine. Question number one, intermediate code. I discussed very early when I was discussing in this PPT. What intermediate code does, it actually takes the input from previous phases, that is semantic till semantic analysis, and it actually provides an intermediate code which can run on different machines. Okay, so there may be possibility that one machine code cannot be compatible for different machine, another machine. So that's why we use intermediate code generator, so that it can generate a code which different machine can interpret in their way. Okay, so that's why we generate the intermediate codes. One can be used by this, two can be used by this. Okay, so retargeting code. Programming analysis is actually part of, you can say, syntax analysis and semantic analysis. Code optimization is already a parser, no, sorry, a phase of this compiler design, and code check is actually done in each phases by error handler, you can say. Okay, so when it out again, or I should continue the example. Okay, so fine. I am going to this maybe last example for today's evening. Okay. So we are given a source program like this. Okay. So the symbol table will like, let's consider there is a serial number, there is a value, and there is a type. Okay, 1 2 3 A B C. These are given as float from this statement, first statement part. Okay, so now just we can just create something like parse tree. Just follow the previous grammar. uh, there is a parse tree, there is a syntax tree also. So parse tree is basically a prototype, and syntax tree is actually what is actually derived as output of syntax analysis. So It is not actual what I am writing. It is just for sake of what semantic analysis does. So just see this. Um, Earlier, what it will generate id is equal to id plus id into some number. This is something done. Id is equal to id plus id into some number will be there. Okay, let's erase this. Okay, from lexical analysis we get this, and consider previous grammar only. What we will get? We will get something like this. Okay, id is equal to id plus id into number. Okay, now here we don't know about uh, their data types. Okay, what is stored in symbol table? So actually the number we are taking it is actually int type. Okay, but all these three identifiers are of float type, what we have declared from previous statement. So okay, now this is from lexical analysis and this is from syntax analysis. Okay, now this kind of syntax tree we have got. The problem I have told is that this is actually int and this is actually float, this is also float, this is also float. Okay, so these three are floats and this is int. So in ideal case it should not be added without typecasting. So let's apply semantic analysis here. Okay, what it will do, it will check this symbol table and the number and it will apply typecasting. So uh, typecastings are actually of two ways. There are two ways. There is implicit, there is explicit. So implicit typecasting is done by compiler, what we are interested in, and it is done by user or programmer in change to float by using yes. Okay, so in semantic analysis we will do this typecasting, implicit typecasting. Okay, so just remember this thing, what we have got, uh, just for the sake of understanding I am writing it like c is equal to a what was the expression, c is equal to a plus b into 60. Yes, as per Singh, please write. B into 60. Okay, I am just not writing, not mentioning id or num. I am just for sake of understanding I am just writing it as this. Okay, so it is float here, it is float here, it is float here. Now we will apply semantic analysis. Semantic analysis, what it does, it will just convert it, this int, to float. Okay, because float is the higher data type in hierarchy. So yeah, otherwise I can say the highest memory state storage data type is typecasted. Okay, so it is done in semantic analysis phase. That is what we say it is semantically correct or not. Okay, so semantically it should not be added with the float, but if we will apply semantic analysis, it will actually convert, it will typecast it and convert it to float. Now we can add it and it will actually provide us the output. So in next phase, intermediate code generation, we will generate generally it uses 3 address code. Okay, what is 3 address code? We have to at most store 3 addresses, at most use 3 addresses. Okay, so like if compiler generate like this, a is equal to b plus c, then a is equal to b and c is equal to 60. Oh, sorry. Just use some temporary variables. Okay, so what we will do first, we will use this and we will just apply typecasting first. Okay, yeah, please tell. Please, if there is any doubt, just comment on this comment section. I will just answer after it. So id1 is equal to id2 plus id3 into 60, something like. Who is this, please? Okay, so t1 is actually uh, let's start with okay, there was some interruption in between. So this was this is actually what we have to use. uh, from here what we get, c is equal to a plus b into 6 b into 60, that is all in float. Okay, so what we have got, we can write it like id is equal to id plus id into 60.0, say. Okay, it is now typecasted. So just for the sake of understanding, I am writing is 1 2 and 3. So we have id1 id2 id3 into 60. Now what we have to do, we can just write into float 60. Okay, then take another variable where we can use this, we can perform this. Okay, id3, we will go like this. Okay, so b that is in id3. Okay, id3 into t1, then another temporary variable id2 plus t2, then we have to store the value in C. So I will take id1 and store the value of t3 here. Okay, so it is like an intermediate code. So in this intermediate code, this code can be used anywhere in different machines. Okay, so that is one thing. Now we will go to either target code generation. How does query language work in compiler and how can it be optimized by the compiler? Query language, take any query language, for example, no, what you are asking, how does query language work in the compiler and how can it be optimized by the compiler? So for query languages, the main task of compiler for query language is to just reduce the complexity in terms of time and space. So if there are some statements which are actually um, uh, vulnerable or redundant, you can say. So what it does, it can optimize this those lines. Like there are four lines and two of them can be eliminated with the help of some kind of optimization. So in that way only. So like we are optimizing this code, we can also in case of query optimization. Or if any one has better discussion about it, can comment here. Okay. So we can generate target code from here, or we can this guys. Yeah, you want. See if there is comment in comment box. If anyone has better explanation than me, then they can comment here. Okay, this is purely open discussion forum. So uh, it may happen that I don't have that much knowledge about that part of topic. So if anyone has knowledge about it, you are open, you can just comment. I will also know about more about that information. Okay. So either we can go through code optimization, then target code, or target code generation, then code optimization, then again target code generation. So I am skipping one target code generation after this. I am just applying code optimization here. Now, So what we will get, um, yes, Yuvant, you can write. So there we have two addresses. We can use it here. Okay, so we can use it like into 60.0, and then id1 is equal to id2 plus t1, like this only. There may be different kind of code optimizations. I am just taking a very simple way. So yeah, you want okay, open your mic and tell if there is any question. No? Okay, you can comment, you can ask. With comment only. So there may be different kind of optimizations. So main thing is if space complexity should get better. Okay. Okay. Now code optimization is done. Then we can say target code generation, or we can say assembly code generation. In most of the compilers from previous ages, this is the main task is to provide a assembly code. One thing more, there is not a kind of attendance I am taking, but if you have to join, just join on time, because in last few minutes, this is only 7 minutes left for this session, so that is not good. Okay. You, who is this?
Yes, someone by the name of Kapoor is disturbing this class.
Don't do like this. Don't do like this. This is bad. If someone is doing it intentionally, that then it's bad. Okay, it's for welfare of you all. So don't do such kind of bad things. I will just remove and block them. But that will just oh, okay. So what I have got from the last one, T1 is equal to ID into 60.0, ID1 is equal to ID2 plus T1. Okay. Now coming to the target code. So we will first load R2 with IG3. We have loaded it to R2. Then we want to multiply R2 Okay, so what it is telling, if you have learned about two address and three address kind of code, so what it is telling that if someone is in this class is intensely doing with the help of his or her friend, then it is very bad. Please don't do this. Okay, we are dedicating our times, so it's very bad. So what this line is telling, we have to multiply R2 with R2, we have to multiply R2 with 60.0. So R2 is multiplied by 60.0 and it is actually stored to R2 again. Okay, so then we are loading ID2. Then we want to add this ID2 with T1 that is stored in uh, R1 only, R2 sorry. So we will store R2 plus R1 in R1 only. Okay, then we want to store ID this R1 value to ID1. So from starting onwards, I am telling again, we have taken this ID3 and loaded it to R2. Now it is loaded. Now we want to perform this multiplication. So we have to perform multiplication. What we want to multiply? We want to multiply this R2 with 60. So we have multiplied R2 with 60. This is the operation. These are the operands, and we want to store it in R2 only. Now R2 is having this ID3 into 60.0. Then again we want to load this ID2. Okay, so this ID2 is loaded to some another register R1. Then we want to add it with T1. What is T1? T1 is this. T1 is stored in R2 only. So R2 plus R1 is stored in R1 only, and in last we have to just import it into or store it into ID1. So we have provided R1 and we store it in ID1. This is the way we can use the three address code generation from the code optimization part. So it is the final target code. Okay, so that is all from my side. Thank you. So any doubt in today's session? If there is any, please comment. It's very bad. It's very bad.
Sir,
Yes.
can we get some more time for assignment submission for week 1 and 2?
Actually, I don't have any authority to do to comment on this assignment timing part. So you can just message on this discussion forum that is provided in this uh, course page. So from there, NPTEL will take care of it. So
Okay, sir.
we
Thank you.
PMRF fellows are actually responsible for problem solving sessions. Last concept
Okay, sir.
is actually okay. Rakesh Kumar. Last concept is actually based upon computer organization. I tried to just elaborate what I have done. So the target code generation is actually converting the any statement to three address code. So if you are not getting it, just go through any book of computer organization and architecture and just go through this 3 address code. Okay, for example purpose I have just tried to explain it. Otherwise, if you are not getting, just comment me in next session. I will again tell. Okay. So thank you everyone. Please join the next session on next which textbook is good. Uh, for compilers, yeah, again, it's very it's very bad. The books they are following is on the course page. I will recommend first go through TOC books, then come to this. Okay, Halman City, then come to compiler design. Okay. So, okay, thank you all. We'll meet next week. Thanks.